Okay. Then we have to pass the presentation again. It's okay.
Yes.
Uh, okay. Okay. First of all, I think I would like to introduce myself. Actually, all of you know me, but it's better. I'm Baris from Turkey. I'm assistant professor in the Department of Computer Science of the Güzel University, which is located in Izmir. It is actually west coast of the Turkey, Mediterranean type city, but not little one. We know each other with Muharrem almost 10 years and maybe more. I don't know. Because we had both same PhD supervisor, and we also worked together in some research projects. If I say something about my research interest, first of all, I think it's better to introduce my PhD thesis. It's related about providing debugging facilities for multi-agent system on DSML abstraction level. So it's my PhD thesis. Beside that, my research interests are model-driven engineering, especially DSMLs, multi-agent systems, especially BDI agents, and soft computing techniques, especially fuzzy logic and meteoristic algorithms. And actually, our collaboration has given me chance to combine all my expertise in a single work. So I'm so happy about that. I'm a little bit nervous because I don't feel comfortable while presenting something. So I take some notes in here, sometimes because I forget my words. And then let's roll the rug and see what happened. In this presentation, you may see some formal definition about cyber-physical systems and smart cyber-physical systems. Yeah, we can define these things formally, like textbooks or articles did. However, if we want to define it, if you want to define it more easily, as far as my concern, cyber-physical systems represent the technological assets of Industry 4.0. Actually, such systems provide a collaborative industrial infrastructure to support integration between cyber and physical domain. In years, the scale of cyber physical systems are going to be larger. The running environments are going to be more open, and system behaviors should be more autonomous. So it causes new demands, such as demand of autonomy, demand of intelligent decision-making, demand of reducing transmission bandwidth, and maybe demand of collaboration between units, etc. So these are pushing designers in smart cyber-physical systems with intelligent mechanisms. So adding intelligence to CPSs makes them be able to support self-adaptation, to build self-awareness, to make reasoning, etc. So these are definitions, and I think that we have to step out to understand what are the challenges in the cyber-physical systems. As you can see, there are many challenges in CPS domain, such as flexibility, autonomy, complexity, lack of intelligence, etc. There are some studies that addresses these problems and also similar problems by combining intelligence system with cyber-physical systems. However, almost all these studies offer a solution to a specific point of development stage or integration stage of cyber-physical systems. However, a holistic view of the problem and of methodology for the designing intelligent cyber-physical systems are still missing. That is why we have to start this collaboration actually. At this point, we may open what we offer a little bit, I think. So as can be seen that there's extremely high correspondence between needs of smart cyber physical systems and offers of multi-agent systems. So we thought that a holistic approach, which could meet these needs, may rise on the shoulder of multi-agent systems. On the other hand, we choose multi-agent system as an infrastructure since it has very major and widely accepted protocols and technologies, especially problematic domain like communication. So I think that I should give a brief description about what is an agent. Maybe you don't know about something about agents, and basically agents are autonomous software entities, which have features like reactivity, proactivity, social ability, etc. Uh, when I said reactivity, I mean that agents can respond immediately events which occur in an environment where they are. Proactivity means that they act according to specified or given purposes or goals. And finally, they can communicate, negotiate, and maybe collaborate to achieve these specified goals. It refers to social ability, actually. Um, and also, we realized that using multi-agent system would not be enough alone. So we need to find ways to improve agents' cognitive abilities and handling abilities of handling uncertainty. So in this case, we bring fuzzy logic on the table. Actually, fuzzy logic represent imprecise and uncertain knowledge and also provide some kind of reasoning mechanism with this knowledge. So we integrated BDI reasoning mechanism, which is reasoning mechanism approach provide agents intelligence and fuzzy logic to make them smarter, actually. Of course, based on our previous experience, we had intuition that it could work, but we need some experience to prove effectiveness of it. So actually, Burak will explain these results in a moment, and you can see that. Okay, now we can come to what is our motivation. It's obvious. We want to propose a holistic approach to develop smart or intelligent cyber physical systems. So there's a question: do we really need things like multi-agent system or fuzzy logic? Yeah, it's of course you can code something like that with embedded C. It's possible. Yeah, but think about that. Well, can you implement a database with assembly? Theoretically, it is possible, but is it feasible? Indeed not. Or you can consider everything in math as an equation. Yeah, it's true, but does it help to solve an integral? No. So you need a appropriate level of abstraction, and all this stuff, multi-agent system fuzzy logic actually gives us this appropriate level of abstraction. So now it's our roadmap. I know that nobody wants to watch a movie with a guy who tells the whole story at the beginning of the movie, but I'm going to be this guy because I want to give you the roadmap of our study, so that you will get a clear picture of things while Burak will explain details. And we started our journey. Actually, I think I can use mouse. You can see my mouse in screen. Yeah. We started our journey to combination between combined cyber physical system and multi-agent system based on simple reflex agent, which gave us reactivity and appropriate level of abstraction. But they didn't cover any intelligent behavior. So we moved to second phase, second phase of our study. So we decide to use agents with BDI reasoning mechanism in there. So it enabled intelligent behaviors. Although it enabled intelligent behaviors, it could not help dealing with uncertainty. And then we passed the third phase, which combined fuzzy logic and BDI agents. Especially, what we did was to blend it to knowledge representation and the ability to make interfaces, to ability to make inferences with imprecise knowledge of fuzzy logic into the BDI reasoning loop. So now you can see that we are here in this stage with this little arrow, green arrow. So it's our main pathway. Beside this pathway, we have a kind of sidewalk in here on the right side of the presentation. We create BDI agent metamodel. We create DSML based on this metamodel, and we are on verification phase, actually based on colored patterns. And so our golden purpose is combine all this stuff together and creating some kind of verification enabled DSML supported fuzzy logic BDI agents to develop smart CPS, something like that. Sorry?
What is the BDI?
I can explain it. I couldn't, I think. Actually, it's a kind of reasoning mechanism to create intelligent behaviors like proactivity. Yeah, so normally agents are just simple reflex. They act and according to some events. But if you want to give some intelligence to agent, you can use some kind of different reasoning mechanism. BDI, one of these actually. Now I want to give the word to Burak, and he will explain what we did in the last 2.5 years. It's your turn. Yeah.
Yes.
Domain-specific modeling language. Sorry for that. I think that you all know that what's the meaning of DSML. Sorry.
Visualization language. It means we generate code and do the analysis.
Yeah.
And for media, think of lots of predefined plans that you have, so that your automation system or cyber physical system can take and play. But you have a correlated relation between those plans and preconditions, post-conditions with the plan.
Like you have a lot of battery right there.
Yeah, but you have a prolog-like reasoning mechanism to reason to select the proper plan, and that brings the intelligence to the table. So it's a kind of reasoning-based system. But another major feature is that it is not purely reactive; it is proactive. So the system can internally do reasoning without.
Because it has a repository of all the plans.
Yeah, so without any action from the environment, it can do a proactive action. Do reasoning and say, okay, it is good, because it has also goal mechanism. So it tries to reach those goals by doing reasoning repeatedly, without having actions from outside. So it tries to reach goals by doing reasoning internally and try to achieve them. In addition to reactive responses.
When you just
You are becoming like Hans Hocam.
Okay, sorry.
No,
I don't want to be like
okay, thank you for nice introduction to Professor Tezel, and I will continue with the Lush part. And of course, the first question that we ask is which agent architecture and where to begin deploying the software agents on cyber physical systems. Yes, and of course, I will continue with the roadmap, and which is marked by the red triangles. So we are there right now. Well, the thing is that we have said that multi-agent systems, they provide modularization, decentralization, autonomy, and reusability. For this purpose, we have selected Jade framework, which uses a Java underneath. And on the physical side, of course, we need an adaptation board, in other words, embedded card, to mimic an industrial system. And in order to achieve this, we also benefited from the Lego as a prototyping technology because it is composable, easy to use, easy to merge, and of course, it mimics the actual industrial system by scaling it down. Well, I have said that we continued with the BDI Pi and Raspberry Pi 3 combination, but how we arrived there? Of course, we had three options. Of course, as I said, Jade is a Java-oriented agent development framework, but we also SPAID as an alternative which uses Python. And also as a device choice, we could go with the EVD3, which all we are familiar with. But as it has low processing power, we continued with the BRIC-Pi combination, and eventually all of them can be used for prototyping systems using Lego. And then by the contributions of some students and we created a kind of complex system that has many stages, as you can see that drop agent, shred agent, sort agent, and push, then build agent. These agents control a portion of the whole system. And how they do that? Of course, the agents, the simple reflex agents, they have behavior types, which is higher abstraction compared to the object-oriented paradigm. And of course, they also perform some social abilities to send messages each other to influence as individual agents to achieve some global goal and perform global behavior. And eventually, we have tested out the limits of the simple reflex agents, and we have seen that on the right side of the system, on the presentation, you see that there is an FSM, simple one. Well, we have used this FSM behavior to program the most complex part of the system, but we have seen that it is quite burdensome, and it brings some also complexity, programming complexity to achieve our goals. And then we have seen that why don't we use BDI agents, because simple reflex agents, JADE or SPAID agents, they are welcomed in the literature. They are applied to the industrial systems as industrial agents, but nobody actually was focusing on the BDI agents, of course. Well, of course, this takes us to the episode 1 and one step ahead. And also BDI agents can provide productivity, and why don't we just benefit from them? Therefore, we defined our scope based on 4 research questions, considering feasibility, integrability, applicability, and of course, the effectiveness. And when we have looked to the literature, we have seen that the use of BDI agents for the cyber physical systems are quite rare. Then we have, and they also focused on robots, multi-robot technologies, not directly on the cyber physical systems. And we have also checked whether there are alternative implementation options to deploy the software agents on the cyber physical systems, but this is also quite rare. Then, based on our research, we have seen a subtle pattern for deploying the BDI or simple reflex agents on the CPS, and we benefited from an architectural design pattern, which is the integrated one, to propose an architecture to show that how we implement our systems and deploy our agents, starting from the environment layer up to reasoning mechanism, BDI reasoning mechanism, of course. And on the left-hand side, we see the abstract form of the architecture, while the right-hand side for you shows the concrete implementation. And eventually, we have assessed and compared the BDI agents with the simple reflex ones, and we have seen that in terms of development time, BDI agents required approximately 3 times less development time compared to the simple reflex agents. Then we focused on evaluating the description complexity. As you see from the figures, we focused on lines of code and number of characters on the program. And then it was resulted that BDI agents require 3 times less description complexity in terms of language expressiveness compared to the simple reflex ones. And eventually, we assess the product quality in terms of some time constraints. And we have seen that product quality is improved up to 66% when the rational BDI agents are used compared to the simple reflex ones. And so far, we have shown that in episode 1, BDI agents can be used instead of simple reflex agents. We can use their proactivity. We can benefit from their reasoning mechanism. But the thing is that so far we haven't implemented anything to deal with the uncertainty, of course, because when we design a sample physical system, it prone to uncertainties, and it should be something that we should consider. So we moved in episode 2, considering enhancements and extensions. And this takes us to the episode 2 on the roadmap. We combine BDI agents with and we gain enhanced abilities for handling uncertainty, applying some extensions on our architecture. But of course, we were a bit cautious. We didn't directly jump into implementing and injecting fuzzy logic to the BDI agents. Instead, we played safe and created a rule-based system and merged the fuzzy inference system, or in other words, fuzzy logic, with the simple reflex agents. As I said, that they have some behavior types, and we just wrap the fuzzy inference system into one of these behavior types to achieve this. And of course, in this way, we have seen that fuzzy logic is doable and uncertainty handling can be provided to the agents. But how about the BDI ones? Because we may require the proactivity, and in episode 1, we have seen that BDI agents can be good replacements for the simple reflex ones. And then we said that, okay, then let's do this for the BDI agents. For this purpose, we extended our research questions, and again, using the same keywords: feasibility, integrability, applicability, and effectiveness. And at the same time, we have extended our architecture. And the enhancement is, of course, for the reasoning mechanism of the BDI agent by providing fuzzy logic abilities. And of course, I underline that we did this in a quite workaround way. And we also provided some extensions, like some things belong to fuzzy logic, like fuzzy functions, membership degrees, and such things are the extensions that are shown on this architecture. And of course, this architecture shows what we did, and how it works is described on the right-hand side by this flow. Of course, basically, in Boolean way or traditional way, we sample the data and we give this to logical inference of the system. Then an agent selects a plan or behavior among the many options. But as we fuzzified this, we this time sample the data, we give this to fuzzy functions or fuzzification units, and we extract a membership degree for that value, which varies between 1 and 0. Then among the set of options, we select the plan that has the highest membership degree, which is the most applicable plan, fuzzified plan. Then within some actuations, such as like turning a motor 90 degrees clockwise, these kinds of actuations are not performed directly. Instead, they are done in a smooth manner using membership degrees. So this provides smooth manipulation to the manipulators and actuators of the system. And of course, this slide describes what we have done for the falsification. Of course, on the left bottom side, we have a sensor, color sensor. We falsified it and we enhanced the sensing abilities of the agent. And on the left upside, most left upside, we have some Lego bricks. And at first, the system Boolean BDI agent was not able to assess all of these and distinguish all of these products or bricks. But by falsifying these and creating some fuzzy rules that are enrolled into the plans, we have seen that the fuzzy BDI agent outperformed the classical Boolean-oriented BDI agent up to 3 times, and based on process harnessing. But this only put 10% more computation time on the reasoning mechanism. And in episode 2, of course, I underlined that we did this fuzzy and logic and the BDI combination in a workaround way. But in episode 2, actually, we have achieved the integration of the fuzzy logic to the internal architecture of the whole reasoning mechanism of the BDI, so that we can provide a general purpose framework for fuzzy BDI agents. And in this way, we can directly program these BDI agents using fuzzy abilities. And of course, this is where we are heading towards, and combining fuzzy logic with the BDI agents and providing hybrid intelligence, of course. And while we are all doing this, of course, we cannot forget about the modeling part. And we, as Professor Tezel said, that we have started to doing the construction of a domain-specific modeling language for synthesizing code, because we don't want to create the code from scratch. We want to generate it, and we also want to provide more abstraction. And at the same time, as maybe Rashid also discovered a bit, the plan selection and goal representation of the BDI agents are quite familiar with the patterns, and as a suitable abstraction, colored patterns were selected to verify the developed plan and BDI program. And of course, this is achieved as static analysis. And we have performed analyses such as boundedness, deadlock, and reachability. And of course, this is the sidewalk. And not over yet, just one more slide. I know everyone wants slices from their pizzas. Well, so far we have only talked about BDI agents as the fundamental paradigm, and also fuzzy logic as a simple logic approach to bring more enhanced abilities to the agents and also the system. But we have seen that why don't we combine multiple logic techniques all together to bring more capabilities to the agents? And of course, let us coin the multi-logic modeling term. It refers to the mathematical formulation, in other words, modeling for enhancement to leverage the smartness of the system. And of course, we don't forget about the multi-paradigm modeling, which refers to modeling for abstraction. And then let me read the whole definition. It's a bit long, but as a result, multi-logic modeling suggests combining proper logic paradigms to provide system-level enhancements, having the BDI agents as fundamental paradigm, as well as benefiting from the NPM philosophy of modeling the system in an appropriate level of abstraction, employing well-fit formalisms to reduce the complexity. And of course, the whole thing can be in the future design described by the FDG plus PM, and also we can provide and show the extensions and extensions and enhancements on the architecture we defined. And of course, the logic approaches can be subjective logic and temporal logic, Bayesian approaches, or epistemic logic, of course, because so far in the BDI mechanism, we haven't done things based on time constraints or timing, and subjective logic is a quite blossoming logic in last 3 years. And fuzzy logic, for example, is a possibilistic approach. How about the probabilistic approach, such as Bayesian? Of course, everything, the whole thing defines a new path towards the future. So thank you so much. If is there any question, I can answer.
Thank you very much. Good timing, except the initial delay. We are finally. We can start eating, fighting on pizza and asking.
Yeah.
Absolutely, yes. You can have it.
Are you using CDN to model the color pattern?
Actually, that thing is from a recent accepted fact. I can show it.
What is the software like? What are you using to?
That's
Not CDN. CDN. But what about the verification? Are you using the verification? CDN to the do you research? Okay. Yeah, in CDN tools. Yeah.
Yeah.
No, so why CDN tools bad? It's quite nice. Yeah, come on.
You start inspecting it and it uses example. Okay, I say and this one your result you can generate, but it's quite
CDN tools is the first you
yeah, but the thing is that it's chip didn't movement. It's not good.
Do you want vegan or spicy and cheesy? Spicy, yeah. Yeah, so this is vegan and that is cheese. Yes.
Yeah, I would be very interested on the see.
Yeah.
If you combine, would it be based on the things based on the
I think I will go for the vegan.
the goal and the environment, which is legal to.
Maybe you can somewhere open the other net life utilities. Yeah. Next one. There's something I have been thinking of last one month. Okay. Yeah. We don't do so strong.
Stairs. So
Also,
it would be interesting to see in the same context because we're talking about the size agents things in one context. But you then
what is the effective ones?
Yes. I'm not sure about the literature which is already there in this. Yeah, seems very interesting.
But we not use the BDI on the line.
You want what or the better? What?
No, thank you.
Or we have orange.
I think
Yeah.
now you play better. No.
And what are the different things in the case study? I see there is sorting, shredding, the stages of the production line, right?
Yeah. So raw agent, yeah, build agent, raw and.
But does the production line actually do something to the bricks?
Yes.
Yes.
There are
Maybe videos on that, I can show you.
Okay, yeah.
I would like to see it.
Yeah, but now it's impossible. But we have in Roma actually some guys are angry to me because
Yeah,
I put some ketchup on the pizzas.
yeah, you don't like it.
Yeah. Once Roma. Yeah, it's the Dutch word for fighting.
So maybe starting from the external members, what is your comment? We have some, do you see some lights there?
Yeah, so we get you faster substages,
Yeah.
episodes,
No.
and this is kind of what you've done next, actually. So I wonder, so these concepts are in the end not new, right? Agents,
No.
but cyber physical system thing is kind of
Yeah.
a hot topic right now. I'm wondering, when you ask these research questions, or when you provide the results, for example, Burak mentioned that there was three times better or something like that. Was it kind of, which aspect of cyber physical system has an effect on it? You normally, when you use the, have BDI agent instead of a, what was the word? Yeah. Yeah. Then you know that it has better qualities, and maybe they are measured in some other contexts. Yeah. Okay. So also, if you use fuzzy logic instead of normal logic or simple conditional things, you know that it's going to, in most cases, it's going to perform better. And there are some measurements on it. But now you are doing it in the context of cyber physical systems. So how the, for example, is it a little bit more better or less better? And what is the how the underlying context has an effect of the relative performance? This is what I wonder.
I think Boris's example was related to that. Huh?
Yeah.
So we try to keep the same requirements, the same functionality, same level of intelligence of the scenarios implemented by reactive code, and you need to go to the details of because you don't have the falsification, you don't have the proactive, so then you need to implement them in a reactive manner. And by doing the same scenarios, implementing the same level of intelligence using BDI programming and having fast. Then we have this, the same functionality scenarios implemented with different paradigms. And then we start comparing, say, okay, how many lines of code do you have here to implement the same intelligence level and or the time that you need to develop this. So this is the context of comparing them.
I think what blue means.
These approaches, were they ever compared in some other context?
Other
Or they may not be exactly the same approaches, but the idea, okay,
So-
the idea be the same.
If you mean because we have another work in progress to compare performance. Yeah, the performance or evaluation of implementing the same scenarios is starting with embedded code, and then Java, then with Jade, then with BDI. So that spectrum, no, we have not discovered that. But that is one of the large the research questions of his program. To see Because for now, we are comparing the reactive agents, BDI agents, and fuzzy BDI agents. Comparing these three.
Yeah.
But if you mean we compare it with the pure embedded code, which is typical in the market, no, we have not compared it now. But that is the idea. So that is one of the ideas to compare with the classic implementation of those. But again, as Baris mentioned, then you go to a low-level code to implement high-level functionality. It is clear that you will write a lot of code, you will put a lot of time, which can lead a lot of bugs, errors, and then repeating the situation. But yeah, the intuition is that the result will be better, but we have not experimented that far with that. Comparing with the classical approaches like embedded code, like embedded C or pure Java, the other layers. For now, we have compared it with reactive agents, proactive agents, and fuzzy BDI. Yeah.
Do you develop this tool to generate that code?
It is the general code generation is all in the program.
Embedded C code or?
For now, it's Java.
JSON, not Java, JSON, yeah. BDI agent code, they directly create, transform BDI.
I really have an even code at low level, or are you going to generate that code?
So for now, Burak is working on generation.
Okay.
But on a high level,
High level.
on BDI,
Yes.
not on an embedded level.
Yeah, but you also mentioned that you want to also do the
Compare.
Yeah, but not with using this as methods, it's separated study actually. Yeah, we do it on manually, on all levels.
Because generating embedded C or embedded code is already there. In a lot of tools, you can model it, you can generate it. The idea for comprehensive evaluation is to compare the line of the code, time, development time, number of errors which can happen for different scenarios, implementing them in embedded C level, in Java level, J level, in BDI agents and fuzzy BDI agents. That one has not been part of.
How did you carry out the development time study? Like, was it with students?
In one of them, it was 4 or 5. Yeah. That is also threats to validity. So because 4 students and from the same domain, I asked, that is why, again, we have another evaluation, empirical evaluation aspect, with rather bigger group. And people from different places.
Maybe through calendars, like something.
Yeah, Flanders maybe, yeah, like Gailani from Turkey.
Maybe my students
Yeah,
from Turkey.
yeah, Malaysian students. So we want to have a bigger group to evaluate that.
That is very nice actually, like big empirical studies are very tough to do, but when you do it, when you have the data.
Yeah.
That's super valuable.
Indeed.
Who coined this stuff?
Yeah.
Okay, but I was going.
It is for oil costs.
So there are, you mentioned proper logic paradigms, right?
Mhm.
I am not an expert on the field, but as far as I've seen, when a new logic paradigm or a new way of logic is proposed, it generally subsumes the other.
Yeah.
So when you say multi-logic, it's not actual multi-logic, you just use an advanced logical paradigm and go step by step. And for example, temporal logic, you also have first order predicate logic here,
Yeah.
and include time.
Yeah.
Yeah, and related operator reliable. So you have to be careful with this one.
Yes.
With this one, we should be careful.
I know, that's when you start.
That is why we are.
Where to start.
That is why we are offering pizza.
Yeah.
To have a friendly discussion, not attack us. Yeah, we haven't discussed this in detail. That is something.
You have an idea.
Yeah.
I understand. Perfect, perfect.
See, they might go on schedule for our presentation.
Yeah.
I would show the roadmap.
And you stop the recording.
No. How do you say that? What do you say?
But that's good, you've recorded the question answer.
Yeah, including question number.
There is another tool. It's very easy to use. It's called OBS video.